Morning, students. Just checking if you can hear me, if you can see the screen. Everybody?
Yes, sir.
Righty. Good, let's go. So I saw some solutions. Some with some mistakes. Some are okay, but that's fine. You learn from your mistakes when you practice the questions. But I say to you, those of you who did these questions and you got anything wrong, you need to redo the question. And those of you who did not do the questions yet, you still need to go and do them even after I do them. All right, so we have 10 questions to get through. I deliberately sent you 10 questions, and I'm going to work through those 10 questions now. All right, hopefully we can finish it within an hour and a half, maybe even less. But let us see. I don't like when these online sessions are too long. All right, so this is a question on the 2024 paper. And I think that year, 2024, this was the May 2024 paper. That's last year actually. Some persons had some issues with this question. All right, even though it's a straightforward question. All right, so it's an application of quadratics question. So we did the topic of quadratics. This is a question where we're applying quadratics to a real life situation. And CSEC like to do that. They like to set questions sometimes where they test your knowledge and test your ability to apply what you learn in the various topics to real life situations. And it is real life situations like these that they also are expected to use for your SBAs. All right, bringing the mathematics to real life and applying them in real life situations. But let's go. It says Laura needs to put mesh around 2 seed beds to protect her seedlings. It says altogether, note they put it in bold, and it's 2 seed beds in bold. Altogether, she uses 60 meters of mesh. That's the length of mesh that she used to go around these 2 seed beds. So the total length of mesh that she uses is 60 meters. Let's make a note of that. All right, because this is the only place this information is located. It says one of the seed beds is rectangular and the other one is a square. The other is a square as shown in the diagram. So clearly this is the rectangle one and that's a square one. It says the width of the rectangular seed bed is x meters. That's x meters right here. That's the width of the rectangular seed bed. And the length of the rectangular seed bed is 3 times its width. So this length is 3 times this width. That's just simply 3x. I'm going to put that information on the diagram. So this length is 3x. So this length over here is x as well. This length down here is also 3x. Alright, we know that's a property of a rectangle. The opposite sides are equal in length. It also says that the length of the side of a square is y meters. That's the y meter shown here. So then each side is y meter. I'm going to put y on each side of this diagram. Question says, using the information given above, derive a simplified expression for y in terms of x. Now, when they say y in terms of x, you're getting a formula that is connecting y and the x, but you want the y to be the subject. That's what they say. Y, that's what they mean by y in terms of x. Y must be the subject of it. And then x, now you get the it's equal to an expression with x in it. So the only information we have is that the perimeter, which is the total distance around the 2 seed beds, must add up to 60 meters, because that's the length of the mesh that was used. All right, so the total perimeter of both seed beds must be 60 meters. That's what we know, because the total length of mesh is 60 meters. All right, so we can make a note of that. Total length, total perimeter then, will be equal to 60 meters. 60, I'm just going to write 60. So the total perimeter is the total perimeter of this plus this. Now the total perimeter of this one is 8x. 3x plus 3x is 6x. 7x, 8x. That's 8x. So the total perimeter of the rectangular bed is 8x. Plus the total perimeter of the square bed is 4y. Y plus y plus y plus y. 4y is the total perimeter of the square bed. 4y. That total length of mesh is equal to 60. That's where we start. But I want y in terms of x. Now this can be divided down by 4. You must always simplify your expressions. Always simplify your expressions. Each of these terms can be divided by 4. Let's put over here. We're going to divide through by 4 to simplify. Divide this by 4, it becomes 2x. Divide this by 4, it becomes y. Divide 60 by 4, it becomes 15. We want to make y the subject because they said y in terms of x. Means that we're going to take this 2x, transpose it onto this side. And so we're going to end up with y equals 15 minus 2x. That is the answer. Y in terms of x. But okay with that? But good with that? Any questions here?
No, sir.
No
Everything's
questions.
all right.
Everything good. Beautiful. Let's go on to the next part.
Sir, can I just take a screenshot of this?
Remember, the session is recorded now, guys. I'm going to send the video of this recording.
Never mind. I can't go down.
Yeah, man, I'm going to send the recording right as the class is over. It is being recorded right now as we speak. Alright, so you'll be able to go back through. Alright, let's go again. It says, the area of the rectangular bed, seed bed, is equal to the area of the square bed. The area of each bed is the same. It says, use this information and your answer in A to write down a quadratic equation in terms of x and show that it simplifies to this. If you notice, this don't have any y in it. So to get that, we basically need to get the area of the rectangular bed, put it equal to the area of the square bed. That's the information they're giving us. Then we're going to have to substitute for the y because this equation has no y in it. We know that the y is equal to 15 minus 2x from above. What they have said here is that the area of the rectangular bed, is equal to the area of the square bed. Area of the square. What's the area of the rectangular bed? It is 3x times x. Remember the sides were 3x and x, right? So the area of that is just length times, which is 3x times x. And the area of this one is y times y, which is y squared. So I'm just going to write 3x times x, which is 3x squared right here. That's the area of the rectangular bed. And that's equal to the area of the square bed is y squared. Easy like that. But then now, this equation has no y in it. So it means that we're going to have to substitute for the y here. How do we substitute for the y here? We're going to take this 15 minus x that the y is equal to and substitute for the y right there. And that's how we're going to end up with an equation with x alone in it. Alright? Alright, so it looks like we're going to run out of space. I'm just put this over here. So we have a little bit more space to work with. So I'm going to make that substitution for the y. And so when we do that, we're going to get 3x squared equals, we're going to square this now. It's going to be 15 minus 2x all squared. You have to expand this now. Now that's a perfect square expanding. Remember, when you expand that perfect square, you must get 3 terms. So we're going to get 3x squared equals 15 squared is 225. Then we'll do twice the product of the two things. How will do twice the product of the two things? You multiply these two things in here first. That's 15 times the minus 2x. That's minus 30x. And then you double that to minus 60x. And then the second term squared. When you square that second term, we're going to get 4x squared. So we're going to get plus 4x squared. That's what we have. And this is actually this equation because when we take this 3x squared, bring it over here and subtract it from that 4x squared, we're going to end up getting 0 equals 225 minus 60x, and 4x squared minus 3x squared is 1x squared, which we can just write as x squared. And this is basically the same equation, right? So this therefore becomes that, right? If we just spin it around, put this on the right, on the left side, we're going to get x squared plus, not plus, minus 60x plus 225 equals 0 if we turn it around, and that has been shown. So we have shown that it comes down to that. But okay with this one now? But good?
Sure.
Understand that? Alright, beautiful. So we have shown this thing, right? We have shown that thing. Next part now tells us to solve this, and they're telling us to use the quadratic formula to solve it. Alright? But to solve it using the quadratic formula. What's the quadratic formula again? It is that x is equal to minus b plus or minus the square root of b squared minus 4ac. Remember now that it is everything all over the 2a. That's the quadratic formula. In this expression that we are solving, the a is going to be equal to 1. That's the coefficient of the x squared term is 1. The b is going to be negative 60. That's the coefficient of the x is negative 60. And the c is going to be 225. And we plug in those values in this quadratic formula. And then work out and see what we get. Alright, let's see what we get. So the x is going to be equal to minus b. When we minus a negative 60, we're just going to get a positive 60. So if you want to put minus negative 60, that's okay. Plus or minus the square root of the b squared. That's a b squared. That's a negative 60. And we're squaring it. Remember, when we square this negative value, it's going to come out to be positive. Right? Minus 4ac. 4 times a, the a is 1. Times c. The c is 225. And then dividing everything by 2a. A is 1. That's 2 times 1. Alright? Now this minus becomes a plus. Let's put a red plus on it. Then I'm also going to use the calculator to work it out. Right? I'm going to use the calculator to work it out. Alright? So I'm going to get two values of x. X equals something or x equals something else. Alright, they're telling us to solve it. So let's go and see what the calculator gives us. Let's see. Usually with these questions, one of the x values that they get, you cannot use. Right? For some reason. If the x value come out negative, for example, you cannot use it. Or if it comes out too large, you cannot use it. So sometimes, what will happen is that one of the values that you get, you cannot use it. It's not a valid value. It does not satisfy the condition. Why a negative value can't work is that x is a distance. X is a distance on the diagram. And negative distance don't exist. So the distance cannot be negative. So that's one example of when you cannot use a negative value. But let's work this out. Let's put this in the calculator and see what we get. So I'm going to try positive 60 for this on the calculator. So it's a fraction. I'm going to try 60. Let's work with the plus first. I'm going to work with the plus first and then change it to minus afterwards. So that's plus. And I'm going to write the square root. I'm going to put this negative 60 squared. But negative 60 squared is the same as 60 squared, right? Same as 60 squared. Because you square a positive or negative number is the same. Minus 4 times a, which is 1, times c, which is 225. And we're putting all of that over 2 times 1, which is a. If you want to put the negative 60 in a bracket there, you're going to see that we get the same result. So the plus is giving me 55.98. If you round that to 3 significant figures, that's about 56. Alright? 55.98. If you correct it to 3 significant figures, it's going to become 50. It's going to become 56.0. So I'm going to put 3 significant figures. 56.0. That's the value of x. I'm going to change the plus right here on the calculator to a minus. I'm going to go back and change it to a minus. Oh, I'm back. Oh man, I'm doing the wrong thing. Man, square root. Sure, I did the wrong thing, guys. So let me go back and put this back under the square root sign. I did the wrong thing. So I'm going to go back. Put this under the square root sign. Put back the minus 4 times 1 times 225. Alright, and then I'm going to come back in and change this plus to a minus. I'm getting 4.02. If I put it to 3 significant figures, that's 4.02. So those are the 2 values for x. Alright? Question said now, calculate the total area of the 2 seabeds. The total area of the 2 seabeds. Remember the seabed, 2 of them have the same area, you know. And the area of one of them is just going to be 3x squared, you know. Alright? If we use this x value, what are we going to get? And if we use this x value, what are we going to get? And we're going to figure out which one of them don't make any sense. One of them don't make any sense, you know. Let me look at it. Let's see which one we have to eliminate. It says solve it. And we got 2 x values. And we want the total of 2 c beds. Now, if the x equals 56, right? If the x equals 56, you know why the 56 can't work? Remember, guys, that the total length of mesh is just 60 meters. See there? The total length of the mesh is just 60 meters. If the x equals 56, then the total mesh that you're using around here will be far more than 60. Because you'd have 56 right here and 56 right here. Gone past 60 already. So it means that 56 is not a valid value for x. So we can make a note of that. So even though we get it in the answer, in the thing there, this is not valid. This is too big. Too large of a value. This is not valid. It's too large. It's gonna defy the information that are gonna be inconsistent with the information that was given. So this is not a valid value for x. So this is the correct x value. This is the correct value for x. So that's the one we have to use to calculate the total length of the 2 areas. Alright? So the total area would be equal to, it's basically 2 times 3x squared, you know. You look at it that way, you know. Because remember, each bed has the same area, and this is the area of the rectangular bed. So if you want the total area, you can put 2 times the area of the rectangle. But that's what I'm saying. Or if you want to do it step by step, you would have to calculate the value of y from this. But why waste time and calculate the value of y? You don't need it. Right? So it's 2 times the area of the rectangular bed becomes the area of the 2 beds, the 2 C beds. Right? So we're going to calculate this. It becomes 6 times x squared. And x is this. So it becomes 6 times 4.02. Right? And you work that out. Maybe this a little bit smaller. I work this out with the calculator. So it's 6 times 24.12 that look like 6 times 4.02. Yes, 24.12. So it's 24.12. You have to say meters squared because they ask for the area of the total of the 2 C beds. And that is it. That's the total of the 2 C beds. 24.12 meters squared. So it means that the area of one of them is maybe what? 12.6, 12.06, half of this. Right? That will be the area of one of them divided by 2, yeah, 12.06. But understand that ends that question. But go to that. But
Yes, sir.
that. But understand why I just did 2 times the area of the rectangular bed? Because if I
Yes, sir.
did the other
Yes,
one,
sir.
it would have to be 3x squared, as the area of the rectangular bed, plus y squared is the area of the square bed. But remember, say them 2 things are equal already, you know. So what a waste time. To do it this way, we would have to go now and put in a value for y. We would have to work out what y is from that. Right? Or maybe put this formula for y down here, so, which is more work, right? So we're doing it the easier way, guys. By just doing 2 times the area of the rectangular bed, which is in terms of x. This is the area of the rectangular bed. And the 2 areas is the same. But that is it. So you're saying yes, so I'll just take that. Alright, that finishes that question. What else did I tell you to do? I told you another question on this paper, don't it? I told you number 4. So this is a revision of basically topics on these papers that we have covered already in the program. That's what I decided to do this weekend. So number 4. So this is one that we just finished the other day. We're on inequalities now, but this is one that we just did the other day. Alright? So let me write the calculator. So this one gives us, it says a rectangle PQRS has a diagonal PR where P is the point -310 and R is the point 4, -4. It says calculate the length of PR. That's the length of line formula. Length of line formula. So length of a line, remember, is the square root of the difference in x squared plus the difference in the y value squared. That's a quick way to remember the formula. Comes from Pythagoras' theorem. Alright, so this length using these values now is going to be equal to the square root. The difference in these two x values we're doing. Notice that one of them is minus. So I'm going to do 4 minus negative 3. So it's 4 minus negative 3. That's the difference in the two x values. Or you could have put negative 3 minus 4. Same thing. Alright, if you subtract them the other way around. That's the difference in x values. Plus, difference in the y values now is negative 4 minus 10. Or it can be 10 minus negative 4. Negative 4 minus 10. That's this y value minus this y value. A lot of persons made mistakes with these negatives, so learn from your mistake now. This works down to be the square root of, this becomes a 7 squared. Plus, this becomes negative 14 squared, as same as 14 squared. And that's what we're working out. Let's get a calculator. And let's do it quickly and see what we get. I think some person put it in the calculator and get a third form for the result. But let me see what the calculator is giving me right here now. So it becomes the square root of 7 squared plus, that's 14 squared. The negative 14 squared is the same as 14 squared. That's 15.6. Or if we leave the answer in series form, as some calculator will give, some calculator might give it this, which is acceptable as well. 7 square root of 5. So 7 times the square root of 5, and you have to write units as a length. Alright, 7 root 5 units, right? Or you could write this 15.65 or something like that. But I'm going to leave this one. Actually, I saw somebody give it to me like this in the solution, which is fine. Then it said determine the equation of the line. Alright. So they're asking for the equation. Now remember, to find the equation, we need to know two things about the line. We need a gradient and a point. We have 2 points. We can use any one of them. But we need to find the gradient first. Alright? So let's do the gradient first. So the gradient of PQ equals, remember now, it's rise over run, which is difference in the y values over difference in the x values, because it's rise over run. The direction you go for the difference in y, you must go the same direction for the difference in x. That's all we need to remember. So the gradient of PQ equals, now let's say we're using this point minus this point. We have to subtract them in a consistent direction. So it's this y value minus this y value we're using first. So it's going to be 10 minus a negative 4. If you subtract them that way. And since we start with this y value when we're taking the difference in y, we have to start with this x value for the difference in x. So it's going to be negative 3 minus this 4. So it's going to be negative 3 minus 4. Now the numerator becomes 14. The denominator becomes negative 7, and that therefore is negative 2. That's going to is negative 2. Now which point are we going to use? Which point are we going to use? You can use either the P point or the R point. Doesn't matter. Let's say we decide to use a P point. If I'm using the P point, then the equation is going to be y minus yp equals the gradient PQ, not PQ, is PR. I'm writing PQ, but it's actually PR. So formula with PQ. Right? So it's gradient of PR into x minus xp using the point P. Alright? Let me write down what P is. P is a point. What is it again? Negative 310. Negative 310. So it becomes y minus the y value at the point is 10 right here. Equals the gradient we just worked out is negative 2 up there, so into x minus the x value at the point is negative 3. Negative 3. This minus minus becomes a plus. Let's put that plus on there in red. So it actually becomes a plus. And what we can do now is expand with this negative 2 over there. And so we have y minus 10 equal negative 2 times x is negative 2x. Then negative 2 times positive 3 become negative 6. Then this 10 goes over and becomes a positive 10. And so it's y equals minus 2x minus 6 plus 10. Then the 10 minus 6 is plus 4. So the y equals minus 2x plus 4. And this is the answer for the equation. This right here is the answer for the equation. But okay with that? But good?
Yes, sir.
Yes?
Yes, sir.
Alright, beautiful.
Yes, sir.
The same thing we do in class, the same thing we see on exam papers, right? Alright, here now is a functions question. I don't think I need the calculator for this now. Here's a functions question. So it gives us these two functions, f and g. First part says, find in simplest form an expression for f of x minus 2. So it means that all we have to do is take the x minus 2 and put it in the f function. That's all we have to do where the x is. Right? Because if this is f of x, then f of x minus 2 means that that becomes x minus 2. So this is just simply equal to 3 bracket x minus 2 where the x was plus 1. And I want us to simplify it. Expand this out. It is going to become 3x minus 6 plus back this one. The negative 6 plus 1 is negative 5. So reduce it to 3x minus 5. Easy as that. What go with that? What okay?
Yes, sir. Yes, sir.
Beautiful. Then I want g of 3x plus 10, 3x plus 2 plus 10. Let's try what gx is again. G of x is again. G of x, remember now, is x squared. Is it? Yes, x squared. So therefore, g of 3x plus 2 means I'm going to take the 3x plus 2 and put it there so for the x. And then we'll add back the 10. So this then becomes equal to the g of 3x plus 2 becomes 3x plus 2 squared. 3x plus 2 squared where the x was up here. That's the g of x plus 2. And then we're adding 10 to that. Plus 10. You have to expand this perfect square. Remember, when we expand a perfect square, you get 3 terms. So the first term squared is 9x squared. Then you get twice the product of a 2. How do we do twice the product of a 2? Multiply these two things first. That's 3x times 2 is 6x. And then you double that to 12x. It's plus 12x. And then the second term squared is 4 because this 2 squared is 4. That's what we get when we expand this bracketed term. We have to add back this 10 beside it. And so to consolidate everything now, we're really now just adding the like terms, the 10 and the 4, to give us 14. So this reduces to 9x squared plus 12x plus 14. And this is the answer in simple form. You can't simplify it further. 3 unlike terms. That's a trinomial, a quadratic expression. What to go with that? What okay?
Yes, sir.
Alright, beautiful. Let's continue. Oh, that finishes that question. Nice. This is 2024, guys. I think there's number 8 we're to do as well. Number 8 on this paper. So this is basically an indication of how many topics we have covered that we should be able to do on this paper. Alright? So it's kind of indicating how far we have gotten to. So we're at the stage where we can do 3 out of the 10 questions on this paper. 3 out of the 10. And number 8 now is function. Oh, another functions. Wow, this is a second functions question. This one. Lucky. This one gives us f and g. And first part wants g of 2. So this is your traditional now. So you're going to put the 2 in here. In the g function. That's going to work out to 5 minus 2 squared. 2 squared is 4. So that's 5 minus 4. 5 minus 4 is 1. That's that. Next part wants f to the minus 1 of 3. Alright? So we can do this 2 ways. You can find f to the minus 1 of x first and then plug the 3 in it. But I've been showing you another way that we can do this. Alright? Let me go that way again. We're going to call f to the minus 1 of 3. We're going to call it some value n. Still have to transpose. Then it means that the 3 is equal to f of n. So therefore the 3 is equal to f of n. Right? If f to the minus 1 of 3 is n, Then 3 is f of n. Now when you calculate the value of n, you have your answer. You know? So the 3 then is f of n. So f of n is found by putting the n in this function. Alright? So that becomes 2n minus 1 over 3. So you still have to transpose. Still have to make this a subject. We use the inverse method or not. So we transpose everything away from this n. When we find the value of that n, that's the answer that we want up here. Using this method. So the first step is to take this 3 and multiply it across here by that 3 and get 9. Which is 9 equals 2n minus 1. To make this n the subject now, we're going to take this 1, bring it over here and add it, and then take this 2 and divide it. We must cancel that in a step now. So it's going to become 9 plus the 1, and then divide the 2 under here. Over 2, that is what is equal to n. That's 9 and 1 is 10. 10 over 2 is 5. So the n equals 5. Therefore, f to the minus 1 of 3, which is equal to the n, is equal to 5. That's the answer. So if you do the other way and get 5, no problem. No problem. So it could have been that you find f to the minus 1 of x first. You still have to transpose this anyway. So any method you use, you still would have to transpose this and make this a subject. You cannot get away from it. Whichever method you use. But this is the answer that we want. 5 is the answer. Better go to that?
Yes, sir.
Alrighty. Whichever method you use, 5 is the answer. Next part wants us to derive f of g. Let's write down what they are again. F of g. So the f, remember, is 3x minus 1. It's 3x minus 1 over 2, right? And the g is 3x minus 1 over 2 or over 3. I'm wrong way around. No, it's 2x minus 1 over 3. It's 2x minus 1 over 3. 2x minus 1 over 3. And the g is 5 minus x squared. The g is 5 minus x squared. Those are the two functions. And we are now forming f of g. So we're forming f of g of x. Remember this, guys. F of g means g into f. Shortcut. Means that it's taking all of this g. They're going to bring it and put it into the f right there. That's how we make it. That's how we make that composite function quick and fast. That becomes 2 times all of g is 5 minus x squared. Minus this one beside it. And everything is divided by this 3. Alright? That's the expression. But I want us to simplify it. So I want to simplify it. And it's going to be that. Let's just work it out. It's going to be 2 times 5 is 10. 10 minus 1 is 9. So we're getting a 9 on the numerator. There's 2 times minus x squared is minus 2x squared. And everything is divided by this 3. Okay, I'll leave this as the answer. Right there. But go to that. Let me make this a little smaller. But okay with that?
Yes, sir.
Alright, beautiful.
Yes, sir.
This right here is the answer, guys. This right here is the answer now. Alright, beautiful. Beautiful. Anything else? Number 8. It says, sketch a graph of g of x in the space provided below. On the sketch, indicate the maximum or minimum point and the roots of the function. Wow. So they want us to sketch this graph. They want us to sketch this quadratic graph. 5 minus x squared. Alright, let me see what the easy way we can do it now. Without practicing points. Let me put it up here. So we want to sketch g of x equals 5 minus x squared. Alright, first, that's gonna frown. Right? And this is just C. And let me show you something now. How can I use up what we know to sketch this graph quickly? Right? How can I use up what we know to sketch this graph quickly? I want to use up our quadratic knowledge that we have to sketch a graph quickly. Right? So I'm gonna write it in this form. A into x minus xt squared plus yt. And that's what we learned in class. Right? X minus xt. So this would be an x squared term. So it's going to be x minus 0 It's just x squared alone, so it will become minus, that's what this is going to come, minus 1 or minus x minus 0 squared. So it means that the xt is 0. Xt is 0, right? And it's going to be plus yt. Yt is 5. So it means then that your maximum point is xtyt. Xtyt. I'm just showing you, relating it to what we know. So your maximum point xtyt is the point 0, 5. And 0, 5 is on the y-axis. That's where the maximum point is. The next thing they ask us for are the roots. And you find the roots by solving this equation equals 0. So let's do that part. Now remember, for the roots, you have to solve the equation and put it equals 0. So it will be 5 minus x squared equals 0. We transpose the x squared over here, you get x squared equals 5. And then to find the x, you would square both sides. And so x would be equal to plus or minus. I could factorize this too, let's do it another way. No, let's just do it this way. X would be equal to plus or minus 5. Plus or minus square root of 5. Plus or minus square root of 5. If you square root both sides of this, you have to consider that it's plus or minus. So x will be plus or minus the square root of 5. Alright? That's plus or minus what? But the question did ask us for the roots. Let's see what the square root of 5 is. In terms of value, so we can estimate where it is on the graph. It's just a sketch, so you still don't need the 100% accuracy. So square root of 5, square root of 5 is 2.24. 2.24. So the x roots are plus or minus 2. Let's just say 2.4. 2.2. 2.24. Almost 2.2, right? 2.2. Alright, so we're going to put these on the point. So this is the maximum point. Let's underline them in blue. That's the maximum point. And these are your two roots where across x-axis. Because the square term is negative, it's going to have a frown shape. Those are like some of the important things. It's going to have a frown shape. Alright, and we're doing just a sketch. Alright. So let's say we scale it up a little bit. This will be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then it should be 1, 2. Let's make this x scale a little bit wider. Let's make this be 1. 1, 2, 3. And then this will be minus 1, minus 2, minus 3. Alright, let's put on some critical points now. So it's going to turn at 0, 5 up here. Up here is going to turn, the maximum point, right? And then it's going to go to 2.25, 2.24, positive and negative. Where would that be? Let's see. So this is like 2, 2.1, 2.3, 2.1, 2.2, 2.3, 2.4, 2.5. Looking for 2.23. So 2.1, 2.2, 2.23 maybe about right here. So you're going to cross x-axis right there. So, and same thing over this side. Negative 2.2, negative 2, negative 2.1, 2.2, 2.3. So maybe somewhere around here. Gonna cross x-axis. Just need to sketch that now. A frown that passes through these 2 points and turn up here. So I'm gonna just sketch it like that. Those are the points that they said that we had to show. So this point is the maximum point. 0, 5. Question asks us to show the maximum point and also shows the two roots. So the two roots are, this is positive root 5 and this is x equal negative root 5. So that's a root, that's another root. That's what they wanted us to show. The shape is a frown. That is it in a nutshell, guys. That is it. What do you go with that? But okay?
Yes, sir.
Yes? Alright, beautiful. So it's an application of quadratics that we just did, right? That's not the only way to do it. I think some person may be able to plot points and all of that, but that is waste of time because the question did say sketch. Once I say sketch, you don't need 100% accuracy. You just need to be showing the critical things, which is a shape, which is a frown, show it crosses the y-axis, show it happens that the y-axis intercept is also the maximum point, and they specify that I wanted to show the roots. Remember, the roots is where you put the equation, put the expression equals 0. That's what we did here to find the roots. Alright, put it equals 0 because on the x-axis where the roots are, the y value is 0. And basically that is it. We'll put plus or minus root 5 as the roots. Plus or minus root 5 as the roots. Alright, that is that question. I think that finishes that. Oh, there's a part B here now. It says, the graph below shows a quadratic function. It says, on the grade above, draw the tangent. Oh, use the tangent draw to estimate the grade. Alright, we don't do this yet, guys. I'm going to leave out this part. We're going to do this at some later, but we can show you still what they expected to do. Alright, even though we don't do this at that topic yet. Let me just give you a quick explanation of what is happening here. They want us to draw the tangent at the point where x equals 1 on the graph. Now, x equals 1 on the graph. X equals 1 on the graph is here. This is x equals 1. On the graph, it is this point. Alright? So, the question is start asking us to draw a tangent on the graph at this point. This is the point where x is equal to 1. So, the one there for the x value. So, a tangent is a line that touches the graph at that single point only. Just touch it and appears to be running parallel to the graph at that point. So if I zoom it in, you're really supposed to be drawing a line. You put your ruler against the graph, like against here, something like this. Put your ruler like that, right against the graph, and you draw your tangent, right, such that it just seems to be touching the graph along the ruler there. So, something like that. That red line would be a tangent that appears to just touch a curve at this point only. Something like that. Right? That would then be your tangent. Let me remove this blue as if it was a ruler. And that would be the tangent, maybe at this point, something like that. Right? Maybe we could draw a little bit better. Let me draw it over. Draw it in the red still. So you just want a line that touches the graph at this point and appears to just touch the graph at that point only. This is something we're gonna do in class. This is the tangent. And what it is, guys, is that the tangent, the gradient of this tangent and the gradient of this curve at this point is the same. You see, what happens is that where a line has one gradient, one constant gradient throughout, a curve has different gradient at different points. Each point on a curve, the gradient is different, because as you go along a curve, your direction is changing. So as you go along a curve, the direction is changing. So because the direction is constantly changing, the gradient is also changing. And so when it comes to a curve, you have to specify the point where you want to find the gradient. And so at this point, the tangent and the curve, they have the same direction, and so they have the same gradient at that point. And so at CSEC level, if you want to find the gradient of a curve at that point, you draw the tangent to the curve at that point, and you calculate the gradient of the tangent. The gradient of a tangent is the same as the gradient of the curve at that point. Alright? So that's why they're asking us to draw the tangent. And this point is the point 1, 3 right now. I'll put it on blue. This point is the point 1, 3. This point is 1, 3. See, 1 is the x value. Clearly 3 is the y value at that point. To find the gradient at this point, we need to find another point on the tangent. Find another point on the tangent. And then use those 2 points on the tangent. Calculate the gradient between those 2 points. And then now use that gradient of that tangent as the gradient of the curve at that point. So I'm not seeing 2 clear points right now. So I have to basically extend this tangent further down until we can see if we can find another point. All right, let's say this is another point on the tangent right here now. Let's say that that's another point on the tangent. What point is that? That point is 0, -2 on the tangent. So by using these 2 points now to find the gradient of a tangent, we are getting the gradient of a curve at this point. Alright, so I'm just giving a quick explanation, even though we have not yet done this topic in class. Alright, so it says, use the grid, draw the tangent at x equals 1. That's the red tangent right there. Then it says, now use the tangent drawn to estimate the gradient of a curve at x equals 1. You see that? So by calculating the gradient of a tangent between these 2 points, we are getting the gradient of a curve at this point where x equals 1. Where x equals 1 is the point 1, 3. Alright, so that gradient of the curve at x equals 1 is equal to the gradient of the tangent. That same tangent, which now is the gradient between these 2 points. Same way, difference in y by difference in x. So it will be 3 minus -2. 3 minus -2 divided by 1 minus 0. Divided by 1 minus 0. That works out to be 5. So the gradient here now, based on this sketch, will be 5. Even though it's a quick, rough explanation, guys. Think you understand what I've just explained? You understand it? You can listen back the video and listen to the details of the explanation as I just gave. That the gradient of a tangent is equal to the gradient of the curve at that point. When you talk about the gradient of a curve, you have to specify the point where you want the gradient on a curve, because each point on a curve has a different gradient. Because each point on a curve, the tangent, the direction is different. And at that point, the tangent and the curve, they have the same direction, hence they have the same gradient. And this is a good way of estimating the gradient of a curve at a point by drawing a tangent to the curve at that point and calculating the gradient on that tangent by finding 2 points on that tangent. Alright, so let's see about the video to that explanation, please, and see if you can understand. We're going to practice this in class, but not yet. Not yet. But alright with it though? Think you're okay?
Yes, sir.
Yes, sir.
Huh?
Yes, sir.
Alright, beautiful. So if you didn't do it, I want you to go and do it. Take your ruler and draw it and all of that. Alright, see if you can print out the thing that I sent you and try and do it yourself. Alright? Alright, let's go. Next part says now, write down the equation of a tangent. So the gradient is 5 and the y-axis intercept is -2. So we're good to go, right? So for this gradient, the gradient is 5 and the c is -2. And once you have those two things, you can write the equation. So the equation becomes y equals 5x, gradient is 5 and the c is -2. Done, that's it. Nice and easy. Nice and easy. Hold on a second, let me take this call. Hold on a second. Hello? I'm in class now, you know. What's up? Huh? No man, I gave it to Dante. Dante added it to it. Yeah man. Alright guys, sorry about that. I'm at work actually. Alright, I think that finishes this question. You might not do all of them today, you know. But that is just what, 2, 3 questions so far. Somebody calling me again. Hold on a sec. Hello? What's up? Talk fast, I'm in class. Alright, when you have to remind me after because I'm in class now. Cool, yeah. Alright guys, sorry about that again. Alright, let's do the next paper, question 4 and 8 on the January 2024 paper as well. Alright, let's go to that now. January 2024. Let's see if we can finish all of them. Yeah, we can finish all of them. January 2024, this paper. I think there's only 2 questions on this one we have to do. Alright, number 4. Let's go down to number 4. Number 4. Number 4. Where are you? Number 4. Here you go. Number 4 is a functions list. Quick and fast, guys, because we're supposed to master this now, you know. So give us these two functions, f and h, and I want us to find f of 4. So we're going to put the 4 in the f function right there. That's going to work out to 2 minus 5 times 4. 5 times 4 is 20, so that's 2 minus 20. 2 minus 20 is negative 18. Done. Then we want h of 0. It's going to put the 0 in the h function up here. And so that's going to become 5 to the 0. If you use a calculator and do it, you're going to get 1. But you should know that any number raised to the power 0 is 1. This is something that's good to know. The more things you know, the better. So this is actually equal to 1. Any number raised to the power 0 is 1. Answer for this one is 1. Next question. F of h of negative 2. Remember, f of h of negative 2 means that we're going to put the negative 2 in the h function first. Do this part first. That becomes f of h of negative 2. Remember, the h is 5 to the 0. 5 to the x, sorry. So that's going to become 5 to the negative 2. 5 to the negative 2. Now, 5 to the negative 2 is like 1 over 5 squared. This is like 1 over 5 squared. That's what the negative power means. 1 over. It's a reciprocal. So this is actually f of 1 over 5 squared, which then becomes f of 1 over 25. 5 squared is 25. 1 over 25. If you didn't know, you could use a calculator and work this out, you know. Then we want f of that now. What is f again? The f is this. 2 minus 5x, right? So the f is 2 minus 5x. That's what the f function is. So it means that we're taking the 1 over 25 now, putting it here for the x. Right? To get the f of 1 over 25. So it becomes 2 minus 5 times 1 over 25. So it becomes 2 minus, now this 5 cancels into 25 5 times. It becomes 2 minus 1 over 5. And then this 2 is same as 10 over 5. I'm going to say 10 over 5. I'm going to multiply it by 5 and divide it back by 5. So it's 10 over 5. So it becomes 10 over 5 minus 1 over 5. And 10 minus 1 up here is 9. So the answer is 9 over 5. But maybe if you use a calculator, you get all of this still, quick and fast. But that is it. 9 over 5, guys. 9 over 5 is the answer. Are you okay with that?
Yes, sir.
Right. Sounds bright and brilliant. Good. Next one, we want f to the minus 1 of x. What is the f again? The f is 2 minus 5x. So the f is 2 minus 5x. I'm going to inverse it. This f becomes x equals 2 minus 5 times. This x becomes f to the minus 1. We are now trying to make this a subject. Alright? Try to make that the subject. What we're gonna do, we're gonna take this minus 5 f to the minus and bring it over here, and take this x and bring it over there. So we're gonna get 5 f to the minus 1 equals 2 minus x. We're gonna take this 5 and divide it under this side, and so we're gonna get f to the minus 1 equals 2 minus x all over 5. I'm putting by the of x now. This is f to the minus 1 of x. That's the answer right there. If you got 2 over 5 minus x over 5, then this is still correct. If you did it another way and got that, it is still correct. Alright, better go to that.
Yes, sir.
Beautiful, beautiful. Next part wants f of f. This means f into itself. Remember, instead of f of f, they could have also given us f squared of x. It's the same thing. Right? Same thing. Same thing. Right, same as right here. Same as f squared. This f of f is same as f squared. Now, how do we form f of f? Put f into itself. Right? So it's like we have f equals 2 minus 5x and f equals 2 minus 5x.
Excuse me.
They form f of f. Mute the mic, please. Mute the mic. You need to take all of f and put it back into itself where x is right here. That is it. F back into itself. Alright? So then this becomes f of x becomes that construct, which is this 2 minus this 5. Then where this x is, I'm putting back all of it. Mute the mic, please. 2 minus 5x. So it is. Alright? That's what we have so far. But I understand that so far? You just need to simplify
Yes, sir.
it. I want it in this form, right? So we need to simplify it. So we're gonna get 2. We're gonna do minus 5 times this 2, gonna give us a negative 10. Then minus 5 times this minus 5x gonna give us a plus 25x. Then 2 minus 10 is negative 8 plus 25x, which is in the same form as this. So this is the answer that we want right here. This right here is the answer. Alright, very good. Before we move on.
Yes, sir.
If you don't understand talking, talk up. Alright, let's go. That finishes that question. Quick and fast. Nice and easy. Quick and fast, nice and easy. The next one we're doing on this paper is number 8. Number 8. So remember guys, just go and watch over the video. Do the question over again. If you made any mistake, if you got anything wrong, go and do it over. If you didn't do it, you still need to go and do it. Mathematics is a doing subject. You cannot learn by watching, just watching sir do the questions. That doesn't work. You have to put pen to paper. Alright? This question says the coordinate geometry. It says the diagram below shows a graph of 2 functions. It's basically still 2 lines, right? On a pair of axes. The lines G and H are perpendicular. So you know they have negative reciprocal gradient. That's what this is about. Once I tell you about perpendicular or tell you about parallel, they are really talking about gradient. So since they're perpendicular, they have negative reciprocal gradients. Alright, this one says we have to determine the equation of line G. This is line G. To find the equation of line G, we need to know 2 things about it, the gradient and the point. Here we can see the y-axis intercept. So we have the C, and we also have this point. Now because we have these 2 points, we can actually measure the gradient. We don't have to waste time and calculate it. We can measure the gradient by counting the rise and counting the run between these 2 points. Count the rise and count the run between those 2 points. So from here to here is 6. That's a run of 6. And then from here to here is 3. That's a rise of 3. So the run is 6 and the rise is 3. And so we have the gradient. Right? So see it here now. For the line G, we know the C is 3. You can see it up here. We cross the y-axis. And the M is the rise over the run between those 2 points. The rise is 3 and the run is 6. When you get a graph, you can count out the rise and count out the run. You don't have to go into calculating. That reduces to half. And so the equation is y equals mx plus c when you know the m and the c. So it's y equals half x plus 3. Done. That is it. That's the equation of line G. But okay with that? But good?
Yes, sir. Yes, sir.
Alright. Next one. Then now one equation of line H. Let's look at what we know about line H. We know that it's perpendicular to line G now. So let's do that first. Gradient. So first, so the gradient of H is minus 1 over the gradient of G. The gradient of G, we just worked it out as a half up the top there. Let's put the G on there. Gradient of G. Gradient of G. Alright? Which is a half. So if the gradient of g is a half, the negative reciprocal of a half is to flip this and change the sign. Remember, the quick way to do this calculation, negative reciprocal, is to flip the one that you have and change the sign. That becomes negative 2. Then H now also passes through this point. We can see that. This point is a point 40 on the x-axis. So we can use the gradient that we just found and that point 40 to get the equation. It also passes through the point 40. So the equation, remember, is y minus the y value at a point, where this is going to use as a point, equals the gradient of line h, is h01, into x minus x value at the point, using this as the point. So it's y minus the y value at the point is 0. 0 equals the gradient is negative 2 into x minus x value at the point is 4. Y minus 0 is just y equals, expand this now, we get minus 2x plus 8, because minus 2 times minus 4 is plus 8. Plus 8. That's the answer right there. Quick and fast. What do you go to that?
Yes, sir.
What happened to that? Or the answer for the coordinates of p. So actually gave us a p on the question, so we can't call this one p. Or give us a p on the question, so we can't call this point p. Let's call this point q then. We can't call it p as well. So let's call it q. Let's change it to q down here. So one change this to q, change that to q, change that to q. Now I want us to give them the coordinates of p. You know what p is? P is the point of intersection of the two lines. So to find p, you're going to solve the two lines simultaneously. The two equations. P is the point of intersection of the two lines. Solve them simultaneously to find p. Right? So this happens at p. That point is valid at, that equation is valid at p. And this equation is valid at p. So we can say add p. The two equations. Y is equal to half x plus 3. And also y is equal to minus 2x plus 8. The two lines meet at p. So the two equations valid at p. So the y value on this and the y value on this is the same at p. So it means that these two things equal at p. If you equate the two y values, they equal at p. So we can say therefore half x plus 3 is equal to minus 2x plus 8 at p. Solve this for the x. What we're going to do first, we'll multiply 2 by 2 to get rid of this fraction. Multiply by 2. We don't like fractions in them. Multiply by 2 to eliminate those fractions first. So multiply this by 2, it becomes x. Multiply this by 2, it becomes 6. Multiply this by 2, it becomes negative 4x. Multiply this by 2, becomes 16. 2, 8, 16. Consolidate now. Take this first, bring it over and add to that x, we get 5x. Everybody can see that. 5x. Take this 6, go over there and subtract from the 16, we get 10. Divide by this 5, x, we get x equals 2. Now when the x is equal to 2, we can take that 2 here and put it right here, so. And then add the 3. Or we can put it right here, so. And then add the 8. Anyway, true. So we can say, and we're going to take it and put it in this one. And so the y is going to be half of the 2 plus 3, which is 4. The y is equal to 4. Therefore, p is the point where x is 2 and y is 4. Let's see if we get 4 on this equation as well. Yes. If we put 2 right here, so it's going to work out to 4 as well. So 2, 4 is that point P. Solve the two equations simultaneously. P is the point where the two lines meet. Better go to that?
Yes, sir.
Alright, beautiful. That have to work for 2 marks, but that's so it goes. 2 marks for everybody, so that is it. Alright, anything else on this question? Part B, the quadratic. Alright, let's go. This question tells us to write this in this form. That's complete the square. Alright, we're going to use our xt and yt method. So we are going to use a into x minus xt squared plus yt. That's not the only way to do it, but that's what we're doing it now at CSEC. What's the A, the B, and the C from this? We need them. Let's work it out. The A is equal to the coefficient of x squared here, which is 4. The B is equal to the coefficient of x, which is negative 24. And the C is a constant term, the third one. Alright? The xt that's coming here is minus b over 2a. Notice I don't give a lot of space to work with, guys. I have to be very efficient. Alright? So the xt is that, minus b over 2a. So it's minus a negative 24 over 2 times a, and the a is this 4 right here. That becomes 24 over 8. 24 over 8 is 3. Remember as well that when your xt is a whole number, you can find the yt by plugging the value back into the function for the x right here and here. We don't have to use the formula method. Right? So the yt then is basically now just plugging the 3 back into the function. Whenever the xt is a whole number, that's a nice quick way to calculate the yt without using a formula. So it's going to become 4 times 3 squared when we plug the 3 right here, so. And I'm going to plug the 3 here so as well and get minus 24 times 3 and then add 31 and work that out. Don't put the calculator, but let's put them on the calculator. You don't bother waste time. Let's put them on the calculator quick. See what that is. Let's just use the calculator quick and fast. So that is 4 times 9, you know. That is actually 4 times 9, because the 3 squared is 9, right? So it's 4 times 9, which is 36. Then you're going to be minusing 24 times 3. 24 times 3. And you're going to be adding 31. That's negative 5. That's negative 5. Minus 5. And the A is this 4. So the expression becomes this. This is the answer now. I'm going to put it here. In this form. So the A is 4 into x minus the xt is 3. Don't forget to put on the square up here, so. And the plus yt is negative 5. So we're going to subtract 5. That's the answer right there. But okay? Xt and yt.
Yes, sir.
Y value at the turning point. Good. Down here now says, on the axis below, sketch a graph of this function, right? Indicating, well, that's an expression, but it's a function they want us to sketch, right? Indicating the coordinates of the maximum or minimum point and the y-axis intercept. Now, the maximum point, let's put over here. Let's put over here in the red. What we know. So, the maximum point, remember, not maximum, sorry, it's a minimum, because the A positive, so it's going to be a minimum, right? The A positive, so it's going to be a smile, a minimum, so it's a minimum point. So the minimum point is xt yt. That is 3, negative 5. The xt and the yt. And then the y-axis intercept, the y-intercept, 0c is going to be 0, 31. And so a sketch we're doing, guys. We're doing a sketch. Alright, so let's sketch it now. So, smile or frown is a smile. You know it's a smile. Where does it turn? It turns at 3, negative 5. Where would 3, negative 5 be? Somewhere down here is 3, negative 5. 3, negative 5 is somewhere down here. Then this point is a y-axis intercept. Has to be somewhere up here. 0, 31. So we need a smile that turns down here and crosses somewhere up there. So we just need to draw that. A smile is going to go like something like that. It's a sketch we're doing, guys, so it doesn't have to be like 100% accurate. Alright, so we're just going to mark it like this. Something like, we're just going to mark it. Something like this. And just put on the coordinates. It's just a sketch. So this point down here is a 3, negative 5. Then I'm going to show it's a minimum point. So it's 3, negative 5. And that's a minimum point. You'll understand if you put min. And the y-axis intercept here is 0, 31. That's what I asked us to show. 0, 31. Right? See, I said indicating the coordinates of the maximum and minimum points and minimum and the y-intercept. But I said coordinates, that's why I put the 0 and the 31, not just 31. Coordinates is plural. You have to show the x and the y value. And that's a sketch. That's a sketch of it. If you wanted the axis of symmetry, it will be the vertical line through here, and it will be x equals the x value at the point is 3. If they wanted the axis of symmetry, if they wanted it, that's what it would be. If they wanted the axis of symmetry, I'm just showing it to you just in case they wanted it. But that is it, guys. That is it. Oh, so ask for the equation down here. I didn't realize. State the equation of axis of symmetry. X equals 3. X equals the xt value, which is 3. Just state it. You have to calculate none. X equals 3. But I said that, I didn't realize I asked for it. But that is it. I'll show it on the graph as well. But okay with that?
Yes, sir. Yes, sir.
Beautiful. Alright. So we have the 2025 January paper to do next. And we have a couple questions on it. Alright. 2025. Let's go. January 2025. What time is it now? Let's see what time it is. 12:90. We're going good. I will start at 11, just 12:19 now. Alright, so we'll soon finish. We'll finish in good time. The 2025 January, let's go. 2025 January. Alright, and I gave you a number of questions on this one to do. So I said you have to do question 2, some of question 2, not all of it. Some of question 2. I don't think I need the calculator now. Question 2. Alright, right, some factorizing and stuff. I'm sure I gave you 2a. This is factorize. This is x squared minus 49. Difference of 2 squared is same as x squared minus 7 squared. Difference of 2 squared. Equal the difference of the values times the sum of the values. X minus 7, x plus 7. That is it. But go to that, factorize that quickly. Difference of 2 perfect square. Good. Then this one's a quadratic. This one's a quadratic. If you're using the process, you have to multiply the n coefficient, which is 1 and negative 35. Let's use the process. This one can be factorized quickly now, but let's use the process to split the middle term. We're trying to split this 2x in the middle. Alright, so we're going to multiply the 1 times negative 35. Then we need factors of negative 35, which is actually negative 35. We need factor of negative 35 that add to the middle coefficient of plus 2. So we need 2 factors of 35 that add to 2. It's 5 and 7, you know. Right? Since we want factors of a negative number, one must be positive and one must be negative. First 2 factors of 35 is 1 and 35. Give the larger one the same sign as this, because you need two factors, one positive and one negative. Right? So make the larger one positive as this that you want, and the smaller one negative. But these now add to 34, which is 2 you want. So the next 2 factors will be 2 and what? Nothing. 3 and what? Nothing. 4 and what? Nothing. 5 and 7. Make the larger one positive, the smaller one negative. Make the larger one have the same sign as that. 7 and minus 5 give you 2, a positive 2. So you have found it. 2 factors that add to 2 is negative 5 and 7. Means that we're going to split this 2x into minus 5x and 7x. Alright? That is it. So this now becomes x squared minus 5x plus 7x. Also split this into minus 5x plus 7x. Could I put the 7x in front? And then minus 35 here. There are 4 terms. We're going to factorize by parts. So we're going for the highest common factor in the first 2 terms first. Right now it's just x. X out of this gives you back an x. X out of this gives you a negative 5. So you want this x minus 5 in the bracket over here as well. You want the same thing in the bracket. So we write back that first, x minus 5. Remember, in between here has to be plus or minus something, not just a value, plus or minus a value. How you know? You can divide this by the x and see that it is a positive 7, or you can divide negative 35 by negative 5 and say it's a positive 7. Anyway you want to look at it, we're getting a positive 7 out here. Then know the x minus 5 is a common factor and they are connected with this x plus 7. Alright? And so it's going to put that in red. X minus 5 is a common factor connected with x plus 7. So then it's going to be x plus 7 connecting x minus 5. And basically those are the two factors. You put x minus 5 in front, same difference. But those are the two factors. Well, good at that. I want us to get to a series. We can just go from this to this, but let us practice this method first. When we master it a little bit more, we can use some shortcut approach to just get that answer quick and fast. But we'll deal with that some other time. But everybody got those two factors? Everybody okay?
Yes, sir.
Yes, sir.
Alright. So this one says, it says hence. You know what hence mean? Hence means that we have to use these results from up here to simplify this thing. What we observe is that on the numerator is the first two factors that we had up here to factorize. X squared minus 49. So numerator is x minus 7, x plus 7. So this numerator becomes x minus 7, x plus 7 over. And then this denominator now is what we just factorize here, which are these two factors, x plus 7, x minus 5. X plus 7, x minus 5. Then you see there's a common factor in x plus 5 on the numerator and the denominator. And so we'll be left with x minus 7 over x minus 5. So this reduces to x minus 7 over x minus 5. And that is your simplified form of that. Very good?
Yes, sir. Yes, sir.
Alrighty. What is? This one says we have to rearrange to make m the subject. This m right here, make m the subject. Alright? First thing I'm going to do, I'm going to take the minus m squared and bring it over here. Take this and bring it over here and subtract. So the minus m on this side, minus m squared comes on the right side. To become positive m squared equals k minus s. Then to make m the subject, we square root both sides. So square root this side and square root that side. And like this square root is cancelled out by that square to leave us with an m. Square root both sides. So I'm going to get m equals the square root of k minus s. But I'm going to put in a plus or minus on it because it can be plus or minus. When you calculate squared, it can be plus or minus. I'm going to put in the plus or minus on this. It can be plus or minus. Right? I didn't quantify if m positive or negative. I think if you don't put this there, they give it the marks just the same. But I think it's good practice, you know, to consider that it can be plus or minus. But I feel like if you just left square root of k minus s, they give it a mark same way. Alright, was really plus or minus. Alright, next part. This part is a kind of, let me see. This one is a kind of, let me see if we're ready for this one. It says, did I say to do C? Let me see, did I say to C? No, I didn't say to C. I'm not ready for to do C yet. Because we're doing this as our next topic. In fact, we're doing this tomorrow and Monday. By the way, if we can have face-to-face class tomorrow, I'm going to have to do it online. I'll know by later. Alright. Well, I asked you to skip out C on this question because this is kind of what we're going to do next, some linear programming stuff. So let me skip out that part. I did tell you to do this though, which is a variations. It says, given that y varies inversely, y is inversely proportional, means k over. So the first thing is k over the second thing, that's what it means. Alright, inverse proportional. And x is 11 and y is 4, y is 9, that's to find k. That's to find k if using the k method. Find the value of y when x is 29. This question can be done without finding the k, but let's use the method of finding k first. Alright, so based on the statement that they gave us, y is inverse proportional to x minus 2. What that means? It means that y is equal to k over x minus 2. That's what it means. And then now, to find the k, we can take this and multiply it over here. So we can say x minus 2 times y is equal to a constant k. Right? So we can take these values now and plug them in this to find the k first. Alright, so let's write that. Find k first using that method. We don't have to find it, but we're using that method of finding k first. Can be done without finding k, but let's just stick to this method that we did in class for now. Find k first. To find k first, we're going to use this pair. X equals 11, y equals 9 in this. Alright, so what would we get? We would get 11 minus 2. That's got to put 11 right here for the x. Times y is 9 right here. That's equal to the k. So this is actually 9 times 9 is 81. So the k is equal to 81. So since the k is equal to 81, we're going to use these two now to get the relationship. So use this and this together to get the relationship formula. So it means that x minus 2 times y is always equal to 81. That's a constant. Right? And here now I want to know what the y value is when x equals 29. So let's take the 29 and plug it in here and solve for the y. So using this now, I'm going to say when x equals 29, you're going to have 29 times 2 times the y is equal to 81. 29 times 2 is 27. Y is equal to 81. If you divide by the 27, you're going to get y equals 3. 81 divided by 27 is 3. So this is the answer right here. But okay with that?
Sir.
Yes?
Yes, sir. Yes, sir.
Right. Good. That finishes that question. And then we have number 4 on this paper to do as well. Number 4. Let's see what number 4 is. Number 4. So as you can see, I was skipping over, going to do them eventually. Number 4 is a coordinate geometry. It says a line segment joins C to D, those 2 points. Calculate the midpoint. Remember the midpoint like an average point. The midpoint is an average point. Let's call it capital M. It's the average of the x and average of the y. It's a nice quick way to remember how you calculate midpoint. So you add the 2 x values, that's the negative 5 and the 7. Negative 5 and 7. And divide that by 2. And you add the 2 y values, that's the 6 and the 2. And divide that by 2, you're taking the average. That midpoint will come. That's a negative 3 over 2. Negative 5 plus, and I put 2 should be 7. It should be 7, guys. Now, pay attention now. This is negative 5 and 7. And this is 6 and 2. So negative 5 and the 7 becomes 2. 2 over 2 is 1. Then this 6 and this 2 is 8. 8 over 2 is 4. So the midpoint is 1, 4. 1, 4. So it's average of the 2 x values. That's these 2 x values. You average them right here. And you average 2 y values right here to get the midpoint. Next part says, find the gradient of the line. Remember, gradient is rise over run. So, it's common MCD equals difference in y over difference in x. Difference in y is a rise, difference in x is a run. Remember now that the direction you go for the difference in y, you have to use the same direction for the difference in x. So let's say we're using this point minus this point. So that's what that y value, the d y value minus the c y value. That's 2 minus 6. 2 minus 6 is the difference in the 2 y values. The difference in the 2 x values is 7 7 minus a negative 5. 7 minus negative 5. This reduces to negative 4 over 12. This minus becomes a plus to get 12. And so the gradient of CD, if you simplify, becomes negative 1 over 3. Okay, this divided by 4 is 1. This divided by 4 is 3. Negative 1 over 3 is the gradient of that line. Negative a third. Alright. At that, anything else? Determine the equation of the perpendicular bisector. See, we do this in class. Let's look at it again. So, it's like you have this line, CD, C, and D. Right? Like you have that line CD. And we're trying to find the equation of this line. See? That's why we do this in class, guys. Let's call this line 2 for now. It is perpendicular. And it passes through the capital M that we found up there. So the point on the perpendicular bisector we're using is M, which was what? 1, 4. And what happened now is that the gradient of this perpendicular line is negative reciprocal of CD. So we're using this gradient. The gradient of line 2, which is our perpendicular bisector, is minus 1 over the gradient of CD, where the gradient of CD that we just found was minus a third. Alright? Minus a third, right? So we're going to have that red perpendicular bisector now. Shall I do this in red, you know? Since the perpendicular bisector we're doing, so let's do this in red. Let's change that out to red to match the color of the line that we're doing. Right. So the gradient of that red perpendicular bisector is the negative reciprocal of this. Negative reciprocal of this is done by flipping that and changing the sign. It becomes 3. So the equation of the line that we want passes through this point and has this gradient. And that's what we need for the equation of any line, the gradient and a point. So the equation of the perpendicular bisector 2, calling it line 2, is y minus the y value at the midpoint equals the perpendicular gradient, line 2, into x minus the x value at the midpoint. That's going to give us the equation. So it's y minus the y value at the point is 4 equals the gradient of the perpendicular bisector is 3 into x minus the x value at the midpoint is 1. 1, 4. Let's make it short. Yes, 1, 4. So it's y minus 4 equals 3x minus 3. When this 4 comes over, it becomes a positive 4. And 4 minus 3 is going to be 1. So this equation reduces to y equals 3x plus 1. That's the perpendicular bisector. 3x plus 1. Everybody okay with that? Everybody okay with that? Everybody okay with that?
Yes, sir.
Alright, this says another
Yes,
line AB is parallel to CD. Let's write what that means. So it means that the gradient of AB is equal to the gradient of CD, which is minus 1 over 3. And passes to the point 0, 1. 0, 1 is a C value. See? 0, 1. That's on the y-axis intercept. So the C equals 1. Write down the equation of line AB. It is y equals the gradient of AB times x plus c. Y equals mx plus c. Once we know the gradient and the c, we're good to go. We don't have to calculate nothing. Just plug them in that. So it's y equals minus a third x plus 1. You must recognize that that's a c point. Y-axis intercept 0, 1 means that the c is equal to 1. It's a point on the y-axis. That's the equation. That's why it says write down. You don't have to calculate nothing. They're giving you everything. Don't need to be doing a calculation. Let's write it down. What good at that? But okay?
Yes, sir.
Alright, that
Yes,
finishes.
sir.
Alright, beautiful. Then we have a last question for the day to do, which is number 8. What time is it now? Right, we're doing it within 2 hours, which is good. I like to do these things within 2 hours on a Saturday. Remember, guys, go and put pen to paper. Right? You can just use the video to assist, to watch back, look back at what we did, if anything, Remind you of what we did, but you have to put pen to paper and do it. Watching sir do it is not enough. Can never ever be enough. This question says the function f and g are defined as this. Now notice for this function that has x on the equal 1 and the denominator, look right here, so. So I put x not equal to 1, because x equal 1 will cause it to be undefined. It will cause the denominator to be 0. That's why they put x not equal to 1. Meaning 1 cannot be in the domain. Same thing we've been talking about with these rational functions. Because that rational function will become undefined if x ever be equal to 1. If x is ever equal to 1. The denominator will become 0. And then the function can't work out. So 1 cannot be in the domain. That's what this is basically saying. So sometimes they ask you, sometimes they tell you. So this time they're telling you that x can't equal 1. Alright? However, it says calculate the value of f of negative 2. Negative 2 is okay. We can put negative 2 in the function right here and work it out. So this is just simply equal to 1 plus 3 times negative 2 divided by negative 2. That's where the x is right here. Negative 2 minus 1. This is negative 6 plus 1. That's negative 5 on the numerator. And negative 2 and negative 1 is negative 3 on the denominator. The negatives cancel, and so the final answer is 5 or 3. I can put 1 and 2/3. Nice and easy. Next part wants us to do f of g. F of g means g into f. We're taking all of this g and putting it in the f right here where the x is and also up here where that x is. Simple as that. That's how we put the g into the f. So that becomes equal to 1 plus 3 times all of the g, which is 5 minus x, over all of the g again, 5 minus x. That's where this x was. We put in all of g there. Minus 1 beside it. I must always simplify. Let's simplify it now. Don't give a lot of space. Now, this works out to be 1 plus 15 minus 3x. 3 times 5 is 15. 3 times minus x is minus 3x. Over 5 and minus 1, this is 4. Minus this x. And let's reduce it further. It simplifies into 16 minus 3x. 16 minus 3x over 4 minus x. That is it. Then going further. Next part says, derive an expression for the, in terms of x, for the inverse f to the minus 1 of f. F to the minus 1 of the f function. So we're doing the inverse of this rational function here. F equals, let's copy it down. F equals 1 plus 3x over x minus 1. Inversing this guy right here. So. Alright. Inversing that one. See, they don't give a lot of space, guys. You see? I keep telling you in class, they don't give a lot of space. We have to be very efficient with our work. What we can do is divide the page in half and half like that. Alright? So let's do it right here. So to inverse this now, I'm going to inverse this. I'm going to inverse it. Make it smaller. Make this a little smaller. Alright. When we inverse it, this f, which is range on the function, becomes domain x on the inverse, equals 1 plus 3 times this x, which is domain on the function, becomes range on the inverse, which is f to the minus 1, over this x also is domain, becomes range f to the minus 1. Range on the inverse function is f to the minus 1 minus 1. We're trying to make this the subject. What we have to do again, as usual, is expand it out into separate terms. Group everything with f to the minus 1 on one side, and then factorize and make it the subject. To do that, we're going to take this denominator and multiply it across here by the x first, as a first step to expand out everything. So it's x times f to the minus 1 first, x times f to the minus 1, then x times this minus 1 gives us minus x, and that becomes equal to 1 plus 3 times f to the minus 1. Then now I'm going to take this and bring it on this side, and take this minus x and bring it on that side. Alright, let's put it up here. So I'm going to get x times f to the minus 1. That's this. This is going to come over here and become minus 3 times f to the minus 1 equals, this one is on the right side. And then this negative x goes over and becomes a positive x. I'm going to factorize the f to the minus 1 out of these two terms. So you're going to get f to the minus 1 into, out of this I'm getting x, out of this I'm getting negative 3 equals 1 plus x. We'll take this x minus 3 and divide it under here now. And so we're going to get f to the minus 1 equals, this as the numerator, 1 plus x over this denominator, x minus 3. And now that we're done, we can stick back in this of x right here. And this becomes our answer. Always stay. We're good? Good at that, guys?
Sir.
Good.
Yes, sir.
We form the inverse, right? We're inversing that function. Some teachers use x and y. No problem if you want to use x and y. Just make sure you get this answer when you're done. Alright? That is it. Bam, 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 bam. What else? What else is there? Oh, that was just, I just told you to do A alone, right? Did I say 8A? Because I'm not ready for you to do this yet. Part B. No, we're not ready for that as yet. So hope I said 8A and not all of 8. Because I'm not ready for that part as yet. We don't do that yet. But I think that is it for today. If I said it was 8A, I was 8. Let me see. If I said 8, I'm sorry. I really only meant 8A. I'm not ready for 8 part B as yet. We don't do that part in class yet. We don't do that in class yet. Let me see what I said. See if I can find what I said. Ah, yes, I did say 8A. Beautiful. I did say 8A. Alright, guys. That's it for today. Quick short session. Less than 2 hours. Which is good. It's always good when you can knock off a class on a Saturday. Like a revision class. But guys, remember, watching me do it is not enough. Right? Keep repeating that. Watching me do it is not enough. You have to go and do it yourself. You here now? You here? Can you reach? May I finish now? So may I come? Yeah. Yes, guys. Watching me do it is not enough. You have to go and put pen to paper and do it yourself. So even if you did not do it before, you have to go and do it now. Alright? You have to go and do the question. You can use the video to help you to get through. So if you don't remember something, look back at the video. But mathematics is not a watching subject. If it was a watching subject, everybody in the Caribbean will get straight A's. Because there's so much material to watch. You have to put pen to paper and actually do the subject, do the questions. You have to practice, do the questions. Alright? All mathematical principles can only be fully understood by solving questions. You have to solve them by yourself, not what somebody solved them. So I'm doing it just as a guide, but for you to actually fully understand it, you have to go and do the questions yourself. Right? And you can just redo these same questions before you go and try others. It's much easier that way. Alright guys, so see you in class tomorrow. I don't know if we're going to have the face-to-face tomorrow. I send a message in the group to let you know what we're doing. But it might be that we have to go online tomorrow and maybe online again on Monday. Alright? I'll let you know what we're going to do. Alright? So bye guys. See you. Bye everybody. Have a good rest of the day. Alright.
Yes, sir. You too.